my name is Katie Nelson, and I'm a third grade math teacher at Dogwood Elementary School in Germantown, Tennessee. Today, I'm going to be teaching a third grade review lesson on solving word problems that involve area. If you have not yet checked out the lesson on area from last week taught by Farmington Elementary School teachers Miss Horn and Miss Lane, I would encourage you to do so, as that will be a great lesson gearing up for today's lesson that will incorporate word problems. So let's just review over some of our essential questions for today's lesson that will help us out as we go through. Number 1, what is the definition of area? Number 2, what is the formula for solving area? And number 3, what are some key words that you might need to look out for in a word problem that is asking you how to solve for area? So our objective today is we're going to be using real-world word problems that involve finding the area of a given rectangle or square. The definition of area is the measurement of the amount of space inside of a shape. And the formula for finding area is A equals length times width. So if we have this shape right here, all of the orange inside of this rectangle is the amount that is filled in, the space that takes up this shape. So if we have a side length that measures 3 inches and a width that measures 9 inches, you can multiply the side lengths together to get your total area. So A equals length times width. Therefore, in this case, it would be A equals 3 times 9. And I know 3 times 9 is equal to 27. So therefore, the area for this shape is 27 inches. So that really got me thinking today about how we use area in our day-to-day lives. For example, my neighbor, I'm selling some picture frames, trying to get rid of things during this time at home, and my neighbor texted me and asked if I had a picture frame that measured to be about 36 square inches. And so I told her I would look, and so the first thing I did is, because I was given the total area in this case, is I wrote down 36 square inches. And I decided to write down the facts that equal 36 that I know. So I always know that when you are looking for two factors to equal the given total, that one can always be a factor and multiplied by itself. So in this case, 1 times 36 equals 36, and therefore 36 times 1 also equals 36. And so now that would be a pretty long, skinny, narrow frame, and I did not have one that measured those measurements. Another fact that I thought of is 6 times 6, and 6 times 6 equals 36. And if I have a total area of 36 and both sides were the same, the length and the width were the same, then that tells me that would be a square, because all side lengths would be the same. I did not have one that measurement either. Now, another fact that equals 36 is 4 times 9. So that would be 4 inches on one side and 9 inches on the other. And 9 times 4. So you could have a measurement of 9 inches on the side length and a width of 4 inches. And I have a star there because I did find a frame that measured 9 inches on the side length and 4 inches going across. So my neighbor was in luck because I had a frame for her if she wanted it. And that just got me thinking really about how we use area in our day-to-day lives. And I know that my husband uses area when he's at work every day, because he works for a builder and he has to calculate area for finding roofs of houses and walls and the flooring in different rooms, so that he can estimate how much the materials will cost when building the house. So area is important in our day-to-day lives. So for today's lesson that we're getting into with the word problems, if you would like to get a piece of paper or two pieces of paper and a pencil, and you can kind of draw things as we go so that you can go back and review later. If you do not have these listed materials, it is totally okay. You will still be able to participate in our lesson by just verbally responding and thinking out loud to yourself as we go through. So we're going to get into solving word problems involving area. And let's just kind of warm up with finding some missing side lengths because we have done this. So I want to review just a little bit before we continue on. So if we have this rectangle here in particular has a total of 10 square inches and one side length is 2 inches, or 2 units, we need to figure out what the other side. So I know that I can divide to find that out. I could say 10 divided by 2 equals blank. And I know that if I multiply 2 times blank equals 10, that the missing length would be 5 because 2 times 5 equals 10. Therefore, 10 divided by 2 equals 5. So the missing width would be 5 square units. Let's do another one. If I have a rectangle here measuring at a total of 8 square units, and I need to take the side length that I know, which is 1. So I'm going to say 8 divided by 1 equals blank. And I know that 1 times 8 equals 8. Therefore, the missing side length in this case is 8 units. So this rectangle measures 1 by 8. All right, let's look at this one. Here we have a rectangle with an area of a total of 15 square units. So I'm going to say 15 divided by 5, which is the width that we've been given, equals blank. And in this case, I know that 5 times 3 equals 15. So therefore, 15 divided by 5 equals 3. So my missing side is 3 units because 3 times 5 equals 15. All right, here we have a total area of 18 square units. So when given the total, I can use division. 18 divided by 3 equals blank. I know that 3 times 6 equals 18. You can always use the inverse operation, which is multiplication and division are inverse operations of each other. So we could say 18 divided by 3, therefore, equals 6 units. All right, and here we have a rectangle that measures 24 total square units divided by a side length of 4 units is equal to 6 units because 4 times 6 equals 24. So I hope that those of you watching that you have been studying your multiplication facts and division facts because those are necessary in almost everything we do. So that's really important. All right, so let's get into an application problem that will lead us into word problems. So if we have a rectangle here and part A says to find the length of a 6 meter by 9 meter rectangle. All right, so I have a side length of 6 meters and a width of 9 meters. So what I'm looking for here is the area. All right, so this should actually say find the area of a 6 meter by 9 meter rectangle. So we're looking for area. So I'm given the side length, which is 6, and a width of 9. And I can multiply those together. And I know that 6 times 9 is equal to 54 meters. So in this case, the area is equal to 54 meters, would be my total area. And as a reminder, if you come to a fact that you do not know, we all know some strategies. You can draw out equal groups. You can draw an array that can help you find the answer. So if we look at part B says use the side lengths 6 meters times 9 meters to find different side lengths for a rectangle that has the same area. Show your equations using parentheses. Then estimate to draw the rectangle and label the side lengths. So basically, what they've done right here is, so if we take 6 times and then we take 9 and break it apart into a multiplication fact. So think to yourself, do you know a multiplication fact that equals 9? If you said 3 times 3, then you are correct. So the first thing that was done was, this is how it was grouped in order to get 6 times 9, because 6 would stay the same, and if you multiply 3 times 3, you get 9, and that's where this 6 times 9 came from for us to get 54. But if we think of a different way to group it, we could put 6 times 3 in parentheses and leave the 3 over here. That will actually change up our multiplication fact, because 6 times 3 is 18. And then we have our times 3 left. So this would actually be a rectangle that equals, still should equal 54 inches. This should not change the measurement, but this actually changes the side lengths of the rectangle. So if I do a rectangle here, and I know that this side length over here, this longer length, would be the 18 meters, okay? And I know that this length, the width, would be 3 meters going across. Okay, so in this situation, I could break that 18, okay, into 2 smaller facts. So I could break, let's see, if I have 18 side length, and I'm going to break it into a tens fact. So if I break that into a tens fact, I could draw like a little line there going across. And so here I know that 18 with a tens fact would be 10, and let's say this one would be 8. So I've broken it apart. So now we have 2 separate rectangles. We still have a 3 as the width, 3 meters. So basically, to find the answer to this, now I could say 10, put that in parentheses, times 3, and then a plus sign. And down here for this rectangle, I would multiply 8 times 3 in parentheses. So now I can solve. I know that 10 times 3 is 30. Bring down my plus sign, and I know that 8 times 3 is 24. And when I add 30 plus 24, if I look at my ones, there's several ways you can add this, and you can always add it vertically going up and down if you would like. But in this case, I'm just going to do my ones. 0 plus 4 is 4, and 3 plus 2 is 5. So that would give me a total of 54 meters. So they both have the same area. All right, moving on, let's get into our word problems. So the area of Theo's banner is 24 square feet. If the length of his banner measures 4 feet, how wide is his banner? Okay, so here we know that area is 24 square feet, okay, is the total area. And I know that this length over here measures 4 feet. I need to find out what the width is, okay? So earlier we practiced with warming up, and we know that if we're given, in this problem, we're given a total area and one side length, then I can use division. So I could come over here and I could say, let's see, 24 divided by the side length given is 4. So 24 divided by 4 equals what? Well, when I multiply 4 times 6, that is equal to 24. So my missing width must be 6 feet. Okay, so the missing width is 6 feet because 4 feet times 6 feet equals 24 square feet. Now, for a little challenge question down here, is there another size banner that Theo could have drawn with the same area? So in your mind or on your paper, can you think of a banner that you could have drawn or that Theo could have drawn that has the same area but 2 different side measurements other than 4 and 6? So think about earlier when I did the anchor chart, if you're given a total, what are some facts that equal that number 24? So we know 4 times 6 because we just did that, and therefore 6 times 4. Can you think of any other facts? We know 1 times 24, and if we have that, we could say 24 times 1. And if on your paper you decided to follow along and list some facts, another fact you might have drawn or listed was 3 times 8 or 8 times 3. So if you did any of these facts, you could have done a banner that is 1 by 24 feet, 24 feet by 1 foot, 3 feet by 8 feet, or 8 feet by 3 feet. Any of those would have worked. So yes, there is another size banner that Theo could have drawn with the same area. All right, let's take a look at this word problem. Here it says the area of a piece of paper is 72 square inches. So I'm going to go in and fill that in because I like to fill things in as I read. So I know the area for this piece of paper is 72 square inches. And it says Margot measures the length of the piece of paper and says it is 8 inches. What is the width? So this side length would be 8 inches. And the width is actually what we're missing for this particular problem. The width is going across from one side to side. So if I know I could use division, then I can say my total is 72 divided by 8. And in this case, I know my facts, 8 times 9, you might have been thinking that, is equal to 72. Therefore, my missing width in this problem would be 9 inches. Now, let's keep going. Let's look at a problem that looks a little bit different. So this one is where we choose a strategy to find the area of a larger rectangle. So in some cases, you might have a rectangle that has a larger factor. So maybe a teen number in this case. And it tells us that Amr is getting carpet in his bedroom, which measures 7 feet. So that's the width going across side to side by 15 feet. So that's the side length. How many square feet of carpet will Amr need? Well, when it's asking me that right here, how many square feet of carpet will he need total? I circle that because those are keywords right there that I know it's asking me what is the area for the carpet that he's going to need. So I'm given 2 factors, 7 feet by 15 feet. So I need to multiply that. And if I multiplied 15 times 7, I don't know about you, but that's a pretty big fact. And I don't know that off the top of my head. But I do know that I can break 15 easily into a 5's fact. So I could say if I divide it here, the line going across, now I have 5 feet by 7 feet. And then down here, the other part of 15 is 10. And that still leaves me with the width of 7 feet. So the 7 did not change. The 15 got broken apart into 5 and 10. So now what I need to do is, if you remember distributive property, when we've done that, I would put in parentheses, I'm going to multiply 5, that part of my 15, times 7, the width that did not change. And then I can simply just add a plus sign there because I'm going to add it to down here. I'm going to multiply 10 times 7. So I can solve parentheses. 5 times 7 is 35. Bring down my plus sign. 10 times 7 is 70. And so now I can add those. And I told you earlier, you can add horizontally, or in some cases it might be easier for you to add it vertically. So I'm going to underline that so that we can add this. And you know that when you add, oops, take my underline off, when you add your ones, when you add vertically, you got to add the ones first. So 5 plus 0 is 5. And then we go over here, and I know that 3 plus 7 is 10. We'll bring my 5 back over. So that gives me a total area of 105 square feet. So the answer is A equals 105 square feet. And that is how much carpet a MR will need. So using that distributive property, there's several steps involved. And if you chose to write that down on paper as we're going, that's great, because then you can go back and review later if you come up with any questions. All right, let's look at another one. Francis washes all of the windows outside of his parents' bookstore. Okay, there are 5 windows, and each window is 6 feet wide and 8 feet high. What is the total area of the windows that Francis washes? All right, so my keywords here, it's asking what is the total area. Okay, so I'm looking for a total, and I know that there are 5 windows. And it does give me the measurement of each window, 6 feet by 8 feet. All right, so I think one way I could do this is I could draw out 5 windows. So I could do 1, let's see, I can do that, and then I can just copy it 5 times. So that's 2, 3, 4, 5. So you, on your paper, if you're going along with us, you could draw out 5 windows. Now, it tells me that each window is the same size because each one has a measurement of 6 feet wide and a side length of 8 feet high. So I can fill those in. Okay, and so I have the same length. Now, it's not asking just for the area of one window. It's asking for the total area of all the windows put together. So this involves a couple of steps. The first thing that I need to do is I need to find the area of one window. Okay, so in order to do that, I'm given my side length times my width. And I know that 8 times 6 is equal to 48 feet. So the area of one window is 48 square feet. So to find that for 5 windows, that would be kind of like repeated addition. So we could simply add 48 plus 48 plus 48 plus 48 plus 48. So we could add up 48, 1, 2, 3, 4, 5 times. Okay, so since that's repeated addition, you could also say 48 times 5. All right, so what I'm going to do is I am going to come over here and I'm going to add 48 vertically 5 times. Okay, and I need a little plus sign here. And then here, I need a little line going across. So, adding up my ones, 1, 2, 3, 4, 5. 8 plus 8 plus 8 plus 8 plus 8. So I know that 8 times 5 is 40. So I got to carry my 4, bring down my 0, carry my 4. And now I need to add up 4 because I carried a 4. 1, 2, 3, 4, 5, 6 times. And I know 4 times 6 is simply 24. So that gives me the total area is 240 square feet for all 5 windows. Okay. Now, there is another way you could have solved that. If you know how to multiply a double digit by single digit number, we could have multiplied, because we were using repeated addition, 48 times 5. This is the way that we chose to solve it today. All right. So now, if we take a look at this side, problem, it says each side on a sticky note measures 9 centimeters. What is the area of a sticky note? Well, thinking about a sticky note, I know that a sticky note is the shape of a square. And I know that on a square, all sides measure the same side. So even though here it gives me one side measurement, I can easily figure out the other side length. The width would also be 9 centimeters because it's the same measurement. So I used my prior knowledge, knowing that a sticky note that I've seen in real life is in the shape of a square, so that would be all the same side lengths. So I know that A, in this case, would equal 9 times 9. And I know that 9 times 9 is 81. So the area of the sticky note would be 81 centimeters. And don't forget to put in your unit of measurement as well. Okay, so we had to think about this. What shape is the sticky note? How do we know? And what do we already know about the sides of a square? So sometimes you have to tap into that prior knowledge and think about, what do I already know that can help me figure out this problem? And in this case, it was knowing that a square has the same sides, same measurement on each side, because all 4 sides are equal. All right, let's look at this problem. It says an artist paints a 4-foot by 16-foot mural on a wall. What is the total area of the mural? Use the break apart and distribute strategy. So we did one like this. So I want you to think about this. Rectangle here, and we know that the width is 16 feet, and this side length is 4 feet. If you break apart your 16 into 10 and 6, then we can use the distributive property. So does anybody know what we could multiply first? If you thought in your mind or wrote down 4 times 10, that is an answer that you could have said, because we're going to multiply 10 times 4. Now this side length is also 4. So the next one would be 6 times 4 in parentheses. And we know that when we solve equations or equations that have parentheses, we have to do the parentheses first. So 4 times 10 is 40. Bring down your plus sign, and 6 times 4 is 24. And 40 plus 24 is, I know my ones, 0 plus 4 is 4. And my tens, 4 plus 2 is 6. So this would be 64 feet. So the area of the mural is 64 feet. Okay, is there another way that the mural could have been broken apart besides using a tens fact? You could have divided it straight down the middle, and you could have broken 16 into 8 and 8. And if you multiply 8 times 4 plus 8 times 4, you should get the same area. So you can break it apart into an addition fact that would work best for you when solving. It doesn't always have to be a tens or a fives fact. All right, here it says a painting has an area of 63 square inches. One side length is 9 inches. What is the other side length? So here, area equals 63 square inches. So this is giving us the total area and a width. So I'm looking for the missing side length. So I could say 63 because it's giving me a total. I'm going to use division. 63 divided by 9 equals blank. So I got to think 9 times 7 equals 63. So in this case, 63 divided by 9 equals 7. So the answer to the side length over here would be 7 inches. All right, let's go to the next slide. Judy's mini dollhouse has one floor and measures 4 inches by 16 inches. So here we have 4 inches is the width, and it asks us what is the total area. So that's my key there. It's asking for a total area, and it gives me the side lengths. So I can use the break apart strategy, and I could say 16. Now I'm going to divide 16 let's see, into a tens fact. So I'm going to use 6 inches. And then down here would be 10 inches. And so now I know that I have to take both parts and multiply them by 4 and add together. So here we would have 6 times 4 plus 10, parentheses, 10 times 4. So 6 times 4 is 24, plus 10 times 4 is 40. And I know that 24 plus 40, 4 plus 0 is 4, 2 plus 4 is 6, it's 64 inches is our total. All right. Now, what we have completed, now that we've completed a lot of problems for practice, let's go over what we need to remember from this lesson today. So we have talked about the definition of area. We know the definition of area is the amount of space inside of a shape. What is the formula for finding the area of a shape? That formula is, say it to yourself, A equals length times width. What is the inverse operation of multiplication that we can use to find a missing side length? We can always use division if we're given the total area and one side length. So if the side length to a shape is a bigger number, say a teen number, what strategy can we use to help with solving for area? So if you remember, we can break apart the bigger number into a fives fact or a tens fact, and then use distributive property to solve for the area. Now, does it have to be a fives fact or a tens fact? No, it does not. It can be another addition fact for that bigger number, whatever is easier for you in solving. You have that choice. What keywords might you see in a word problem that is asking to solve for area? So in today's lesson, you might, in some of the word problems, we might have seen length times width. You might see a question that says, what is the missing side length? You might see a question like this: how much space is inside the shape? So that's kind of incorporating the definition of area. So if you remember the definition, then you would know it's looking for the area. Or you might see a question that simply says, what is the total area? So after today's lesson, you should know how to find area from word problems in a square or a rectangle. So I want to thank you so much for joining me for today's math lesson. I hope this was a good review lesson for you, and I hope that you will tune in again for some more good third grade lessons in the future.